Hi everybody and welcome to this video on incident tracking. In this video, we're going to be discussing some advanced grouping strategies. Remember from previous videos, we discussed some basic grouping strategies. Here, the idea was, for example, that alarms are grouped because they belong to the same service or because they belong to the same device. There are also some more complicated, more interesting grouping strategies, and we will discuss these right now. Now, we have three advanced grouping strategies to discuss. In this video, we'll be talking about relation learning. The idea is that we group alarms because they belong to related parameters. And of course, related here is referring to relation learning. In the next video, we'll be discussing statistical grouping. Here, the idea is that we group alarms because they belong to devices in the same view or devices that are in the same location. This will be the topic of our next video. Finally, in yet another video, we will be discussing grouping on custom property. Here, imagine, for example, that you are in an EPM setting and you have a bunch of amplifiers that all belong to the same node. Now, if there are a lot of alarms on these amplifiers, then this seems to be more of a node problem than an amplifier problem. So maybe you want to group those alarms. Now here you can use grouping on custom properties. What do? You add a custom alarm property that specifies the node to which the amplifier belongs. Then, the next time that our algorithm notices a bunch of amplifier alarms, and the property is always referring to the same node, then DataMiner will automatically group those alarms together. Okay, but that will be a topic, as I said, of a separate video. That's enough introduction. Now let's dive into this. All right. So how do you configure this on your system? Well, I already showed you where you can find the basic automatic incident tracking configurations. Those are just at the typical location in the system center in Cube. However, there are also some more hidden configuration options on your system. Check out the Skyline DataMiner analytics configuration.xml file. You will find such a file on every agent in your cluster. However, remember, for automatic incident tracking, we use a leader agent. There's only one agent that performs all of the work for automatic incident tracking. So it is sufficient that you only modify this file on your leader. You do not need to change it on the other agents. However, watch out. If you change the leader DMA, make sure to change the XML file on the new leader. Indeed, if you change this XML on one agent, these changes are not propagated through to all the agents in the cluster. So if you change your leader, make sure you update your configuration XML on the new leader. All right, so what is in this XML? Well, you immediately see that there are quite some different configuration types. Visitor configuration, relation visitor configuration, statistical visitor configuration, and there's more. Let me explain. The first type of configuration is the visitor configuration. This is a type of configuration that actually only contains one field. You can set enabled to true, or you can set enabled to false. Now, this configuration is used for all of our basic grouping strategies. So you will find an item like this for all of our basic grouping strategies. Here I gave the example of the service property. So this is referring to the fact that we group alarms because they belong to the same service. Now, if you don't want to group based on service, simply set this to false, restart your system, and you're done. The second kind of configuration is the relation visitor configuration. This has an additional configuration option, this relation threshold. Okay, what's this about? Well, remember from the previous videos on relation learning that we find relations between pairs of parameters. So for every two parameters, we have a number that represents how strongly they are related. If that number is 0, then this means the parameters are not related at all. If the number is 1, then this means that the parameters are very strongly related. Now, what does this 0.7 mean? Well, if you configure your relation visitor like this, this means that we will only group alarms on parameters that are related with strength at least 0.7, right? So we will not group additional parameters if they are related only with a strength of 0.6 or 0.5. Okay. Now, of course, if you do not disable these basic strategies, then they will also always be applied. Just to be sure, this just groups additional alarms. Okay. We have two more visitor configurations and we will discuss them in later videos. For now, let's dive into a demo. Voila. So let me get my system and also, maybe a warm appeal to activate your anomaly detection, right? Because we are able to find relations based on alarms and change points. But if you switch off anomaly detection, then our relation learning will be less good because it cannot use the change points. And so our alarm grouping or incident tracking will be less good as well. Okay. All right. So let me fetch that system that I promised. Here we go, ZeneDev. Okay. Now we're going to focus on the following setup. We have actually two identical setups, a live OTT1 view and a live OTT2 view. Now, at first glance, you don't see anything different between these two setups. They have the same kinds of devices, as you can see. The pictures also look the same. But the difference becomes apparent when you open the reports view. So let me open this view and let me open it here as well. Now, let's start with live OTT2. Here you see the historical alarm behavior of those devices. And actually you see that there is not much to learn here. This view was just created by me. And you see that the devices in this view were never an alarm. Okay, let's go to the other one. Here we see a quite different behavior. We see that this view exists already for a long time and that a few times in the past, those devices went into alarm, but they went into alarm at the same moment in time. You see, green means that there was no alarm and red means that there was an alarm. And you see that when the load balancer is red, the other devices were also an alarm. Yeah. Now, this is, of course, the ideal setup for relation learning. Relation learning should be able to learn that those 5 devices are related because their alarms always coincided in the past. Okay, let's see if relation learning is able to group alarms on these devices. What I'm going to do is I'm going to create alarms on all these 5 devices. Voilà, let me show you the alarms that were created. Voilà. Now, let's see if indeed relation learning was able to group those alarms. I'm going to click the hamburger menu, switch on automatic grouping, and what do you see? You see indeed that we have created an alarm relations group. Okay, so far so good. Let's see what happens in the live OTT2 view. Here, no history was available. So normally there will not be any grouping based on relations. Let's verify that this is true. We again create alarms. Voilà ça. And the relation learning is still on. And you see that it is not able to group all of these alarms together. It is able to group a few of them based on other basic grouping strategies, but that's it. Not all the alarms were grouped. All right. Okay, let's clean up everything. And I'm looking forward to seeing you in the next video where we will be discussing statistical grouping. See you then.